Alright, welcome back. This is going to be the first installment of the do-it-yourself CTC system that I'm going to be doing. And I'm going to try and go through each individual component of what I'm doing and then talk a little bit more about next steps. I'm looking for my pointer and it has walked off on me. Oh, here it is. Ah, found it. Right. So, gosh, what to talk about first? Um, I think the first thing to talk about is kind of a little bit of just how this stuff actually works in real life. So, from my understanding of signaling on railroads, there are two types of signals that you see. The first type is an absolute signal, which is controlled by a dispatcher remotely, and the other type is an intermediate, which is not controlled by a dispatcher. It's sort of dependent on other signals that are aligned, or if a train enters a block, which is a space of track in between two signals. So right here, I have a fully functioning control point, and I believe the indication I have set up right now. Let me check my code right here. Let's see. I believe the indication that I have here. Okay, yeah. So right now I have a signal that is aligned clear for southbound going from main track to main track. And basically, I'm going to move around a little bit. I kind of modeled it off of this switch right here. This would be the southbound signal I was referencing earlier. And this is going to be the northbound signal for the main line, and this is going to be the northbound signal for the siding track. So that's kind of how I have this set up. So this was the first signal I talked about. Actually, let me get my pointer out. This was the first signal I was talking about, these LEDs right here. This is the second signal I was talking about, and this is the third signal I was talking about. Now, here I have an Arduino Mega, and it's drawing power from my computer over here. And I have code, I don't know if you can see it, but I have code that's basically telling these LEDs how to light up based on these two toggle switches over here. And I also have a servo to sort of simulate switches and turnouts and things of that nature. But each of these LEDs is powered by a shift register. And essentially what a shift register does is it allows your Arduino to have 8 more pinouts or ports or whatever you want to call them. So basically the way this works is for sort of a two-headed signal, I guess you could call it, for one direction, this would be one signal right here. Now, if it were, say, an intermediate that had 2 heads on it, one for each direction, this one of these shift registers would also suffice for that too. But anyhow, I'm just going to run through how this works a little bit. So I have 2 different toggle switches. This controls the direction that the train's going to be coming. Not necessarily the train itself, but it controls the indication the signal shows based on the direction of the train, if that makes any sense. And this controls the turnouts. So I have a clear southbound main to main, so I'm going to turn this, and you can see that it turns into a diverging clear, and the servo turns accordingly. Now I'm going to turn this back to normal, and I'm going to change the direction to a northbound train. Now I have a restricting signal right here because, and the reason I have this going back to the turnout is because the train's going to be going from here up to here, and it's going to, I'm getting ahead of myself. Basically, the logic behind this is that after this signal, this train is going to stop at the set of stoppers right here, buffers or whatever you want to call them. But that's kind of the logic I have behind using a restricting signal right here, is because right after this one, the train's going to stop. And I'll also use a similar logic for this signal right here, which I will show you. Sorry if I'm too shaky, but I'm just moving around. Now, I'm going to show you based on the turnout. And we see here that the switch turns and it goes to a diverging restricting, meaning that a train is going from the siding to the main, and it is going to stop a short distance away. It's going to be prepared to stop. Now, for a diverging restricting, I also plan to sort of use it up here. For instance, if a train's going from the main to main 2 into the yard, like for example, I have this freight train here, and it's backing into the yard, and basically the logic behind this is to go at sorry, I'm stuttering a little bit. But basically the logic I'm using behind diverging restricting is, or any restricting signal for that matter, is to go through the signal, be prepared to stop. And in the diverging case, you're going through a turnout, multiple turnouts, and be prepared to stop at either one of them in the event that it is not aligned in the favor of the train. And let me get it back to a clear so you can have a better idea of what's going on. Okay, so switch is normal, and the direction southbound. Now, another thing, I have a photoresistor right here, and the way this works is that it takes in light from the room, and it converts that light into bits, I guess, and it sends it to the Arduino, and I can have in my code say, if light level is greater than 300, that's, gosh, what am I trying to say? If light level is greater than 300, that's the level that the photoresistor is recording, and it triggers a time count. Initially, time is 0, and I have this line of code right here, time equals time plus 1. Basically, the function of that code is just to say time starts at 0, and as soon as the light level thing triggers, it goes from 0, 1, 2, just adds on to itself. And I have here, if time is greater than 1, we go to a stop indication. And, else, we just have a clear southbound main to main. So basically in this situation right now, time is at 0 because the light level greater than 300 has not been triggered. But if I move my hand over the photoresistor, signal changes to a stop, the train's rolled over the photoresistor, and it's showing a stop indication. So feel free to ask questions in the comment section if you have any for this. I know this can kind of be a lot to take in, especially for people that aren't familiar with coding. But if there was something I didn't cover in this, please feel free to ask questions. I'll do my best to answer them. But yeah, that's a little bit about my setup, my code, and now I want to sort of get into 3D printing. And this right here is the signal head. This is the only piece, let it focus, this is the only piece that I have 3D printed up so far, and I plan to get others, but the problem I'm running into with these others, see that's a signal face. The problem that I'm running into with these others is that they're not sticking to my 3D printer bed as well as I'd like them to. They're coming up mid-print, and it's just ruining the print, and I'm having a hard time getting a good print. I use a Creality Ender 3 Pro. I have the Creality glass bed, and even with a lot of bed weld being used, my prints still don't stick to the board after a while. I think it's an issue of my bed being level, because I have taken the glass off and I have bumped the little wheels that allow you to adjust the bed. But again, that's just something I'm going to have to sit down and work out. But yeah, this is the only thing I have 3D printed. And basically the way I came about getting these dimensions is I found a picture of a train going by a signal online, and I sort of took a screenshot of that, got the dimension of the engine, the height of it, and sort of took measurements of the engine in picture, and got the measurement of the engine, the height of the engine in real life, and I sort of scaled it up to what it would look like, converted it into millimeters, because from what I've heard, Cura, the slicer program that I use, works better if the dimensions I'm trying to print are in millimeters. But let me see what else. What else am I trying to say? My thoughts are all over the place here. But yeah, basically I just got the dimensions I needed and divided by 87 to put it into HO scale, because HO scale is a 1 to 87 ratio of trains in real life, meaning that, again, I'm going to use my 4501 as an example. This 4501 right here is an 87th of the size of a real 4501. Just for those wondering how this actually works. But, yeah, that's a little bit of what I have going on. I think my next step is to obviously get a signal fully 3D printed, and then move on from there with coding. Maybe sort of finish up this town over here. The name of this town is Corbett. It's named after another one of my friends from college, who even had the opportunity to come with me to watch some trains a few times. So, Ethan, if you're watching this, this is for you. This is for you, my friend. But I pretty much have that working. I'm still debating on whether or not I need to put down scenery before I put down my actual signals first. And I'm leaning towards scenery first. But just a lot going on, and this is just one of those projects that, in order to do it well, I sort of don't need to rush myself and take it in baby steps. But I think I'm going to do this little area, program this area up next as far as coding. But my biggest obstacle right now is 3D printing all of my stuff. So I think that's about it as far as coding and stuff like that goes, and the initial steps I have on this project. I don't know when the next video will be for this, but it'll be when I make my next breakthrough. Probably when I get one of these signals 3D printed and wired up and painted and all that good stuff, so I can show y'all what I have going on. But anyway, this is sort of the initial steps that I have for this. Again, if you have any questions on it, please feel free to ask in the comments section. Thanks for watching as always, and I hope you enjoyed this video. Have a good one.